Let's take a look at SAS Data Accelerator, part of the SAS Data Intelligence suite of tools designed to streamline data movement and accelerate analytics at scale. In this demo, you'll see how processing runs directly where your data resides, which reduces data movement, improves performance, enhances security, and simplifies data pipelines so you can deliver insights faster. Before we dive in, let's talk about the SAS Data Accelerator advantage. With traditional SAS Access tools, SAS can read and write to many different databases, and many SQL operations can be pushed down and executed directly within the database. This provides an efficient way to combine SAS with your enterprise data. However, when complex analytics or SAS-specific processing is required, data often needs to move between the database and SAS for execution. SAS Data Accelerator takes this concept further by enabling SAS analytics and processing to execute directly in database. The SAS embedded process is integrated within each database node, which allows you to efficiently move computation power to the data rather than transfer the data to the compute server. What are the key capabilities offered by SAS Data Accelerator? You can push model scoring directly to the database. You can execute data step code where the data is stored. And when data transfer is required, you can take advantage of rapid parallel loading to ensure data moves efficiently at scale. Initial support includes platforms such as Azure Synapse and Databricks, with additional platforms including Cloudera, AWS EMR, Teradata, and SingleStore to soon follow. Let's see some of these powerful features in action. In this demo, we'll use Databricks deployed in Azure, and we'll run SAS code from SAS Data and AI Studio. You'll see how to score a model using Proc Accelerator, how to execute data step code directly in Databricks, and how to run models from a Databricks notebook. Let's begin in SAS Data and AI Studio. First, I'll assign a lib name to connect to Databricks. This library reference will be used throughout the workflow. Next, I'll create the training input data table, which is simply a copy of the SAS help.homeEquity table, plus an additional primary key column named record_PK. Home equity includes information about home equity loan applications, plus a binary response variable indicating if the outcome was a paid or defaulted loan. This data step loads the data into our Spark library. Next, I'll train the model in SAS using the homeEquity_train table. The grade boost procedure builds a model that will assign a predicted probability for each loan outcome. When Proc Grade Boost runs, it produces two key outputs, an analytics store, or A store, and SAS code that represents the trained model. Before publishing the model, the Proc A store step exports the analytics store. This step also generates a DS2 program, which encapsulates the model logic and will be executed in the embedded process. Now with the A-Store and DS2 program available, I can publish the model to Databricks. Using the accelerator procedure, I specify the target table, the model type, the DS2 program, and the analytics store. After running this step, the model is stored and ready for execution in Databricks. To run the model, I establish a connection to the embedded process, again using Proc Accelerator. The Start Session statement creates a communication channel between SAS and the SAS embedded process running in Databricks. Through this session, code is submitted and executed directly in the database environment. Once the session is active, running the model is straightforward. Use the Run Model statement to provide the model table, the input table, and the output table. The scoring operation runs entirely in Databricks. I'll follow up with a procprint step to view the first 20 observations of the output scored table. After the model is published, it does not need to be executed from SAS every time. Instead, it can be integrated into existing workflows. For example, in a Databricks notebook, the Data Accelerator APIs for Python or Scala can be used to execute the model. In this example, I use the Python API. The input data and the model table are loaded as Spark data frames. Then a model object is created, and we call the score method. This executes the model through the embedded process and returns a result data frame, which can then be stored or used in downstream logic. The same workflow can be implemented using Scala. Now, back in SAS Data and AI Studio, there's another option for model execution. When the grade boost procedure generates SAS code for the model, that code can be run directly in a data step without publishing the model. By enabling data step acceleration with the ds_accel = any system option, then calling the model scoring SAS code with a %include statement inside a data step, the code is pushed down and executed in Databricks. This provides flexibility. You can either publish and manage models centrally or execute the generated SAS model code directly as part of a pipeline. In both cases, execution happens where the data resides. Finally, let's look at a general data step example. Here, I have a data step with a by-group operation. Traditionally, this would require loading the data into SAS, sorting it, and then executing the data step locally. With SAS Data Accelerator, the entire operation is pushed down to Databricks. Sorting is handled using native Databricks capabilities, and no data movement is required. The result is generated directly in the database, which calculated the average mortgage value per state. When processing is complete, the session with the embedded process can be stopped using Proc Accelerator with the stop session statement. This disconnects SAS from the embedded process running in Databricks. One additional point to highlight is the value of the API for automation. Many organizations integrate these APIs into scheduled jobs and pipelines. For example, Databricks notebooks can be included in workflows that run automatically, allowing models to be executed as part of a repeatable production process. You've seen how SAS Data Accelerator brings analytics closer to your data by enabling model scoring and data step execution directly within Databricks. To learn more about supported platforms, deployment requirements, and implementation details, be sure to explore the SAS Data Accelerator product page and documentation.